here is a slightly different graph, and I want to try to figure out what limits might mean in this case. This is a very interesting problem at x equal to 1. Notice that if I'm coming from the left here, so I'm going along, and then my values get bigger and bigger and bigger and bigger and bigger, and what I mean by this, I can't draw all the space, but I mean that it just spikes up here, heading off towards infinity. And then if I come from the right here, it's coming down, 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 and sort of going down towards minus infinity. And then at the actual point of x equal to 1, this function isn't even defined. It's not like f of 1 is some number. So I want to be able to talk about the limits for this particular graph. So the first one is I want to look at the limit. 1 is the clear spot that's interesting. All the other ones, for example, if I want to know what the limit was as it got close to 0.5, I'd be like, that's 0.5. It's just whatever that height is. The limit's not that interesting when you've got this nice so-called continuous graph. But the spot that's interesting is this x equal to 1. That's where I got some interesting behavior where I have to figure out what do I want to do. So first of all, I'm going to do the limit from the left, where I put my exponent minus 1 here. The function that I've graphed is the function 1 over 1 minus x, and you can see that there's a problem at x equal to 1, a division by 0. So what we can see from this graph is because it's going up and up and up and up and up and up, that what we can write down is that this limit is infinity. It's going to get arbitrarily large as our x values get arbitrarily close to 1 from the left. And then I could also ask the same question, but now I could ask the limit, but this time from the right. So as I come from the right, it goes down, 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 and I will say that this is going to be equal to minus infinity. Indeed, no matter how big of a negative number you choose, minus a million, minus a billion, minus a trillion, no matter how big of a number you choose, you could just go closer and closer and closer on 1 until your function indeed got that gigantic negative number. And then if I want to try to figure out what happens to the limit, the two-sided limit, the one where I don't put any exponent, and what I mean is from the left and from the right, both sides put together, well, on the one side, it's positive infinity. On the other side, it's minus infinity. So they're different things. It's not the case that when you come from the left and from the right that you get to the same result. They're different things. And so what we write here is DNE for does not exist. And any time where the limit from the left and the limit from the right go to different values, or in this case, one goes to infinity and one goes to minus infinity, which I don't think of as a value, it's a concept, but nonetheless, it's a different thing, then we're going to say that this limit does not exist. So let's try to define this concept, the concept where the limit as x goes to a is equal to positive infinity. Same, by the way, for minus infinity, you can adjust it. I'm going to say that now my function gets arbitrarily large, a million, a billion, a trillion, however big you might choose. We can accomplish that by getting really, 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 really close, but never equal, really, really close to this value of a. And there's also an analogous concept when you take the limit from the left or the limit from the right, and plus or minus infinity. There's a bunch of different versions, but the idea is always the same. Now, I had to make one little quick caveat, which is that when we talk about a limit being equal to infinity, in a sense is a bit of an abusive notation. The limit still doesn't exist. It's not like we're getting close to some number. In the way, if I say the limit is equal to 7, we're saying we're getting close to some number. So this limit doesn't technically exist, but among all the limits that don't exist, that the infinite limits obey this particular property of getting arbitrarily large. So the convention is going to be that if I ask you for what this limit is, you could say that it's equal to infinity, but you maybe note in the back of your mind that this doesn't mean the limit exists. It doesn't get close to any particular number.